Alrighties, welcome everyone to your pre-lesson video week 3.3 on systems of equations and inequalities. We have a lot to cover, so let's get right ahead. So with systems of equations, there are three methods to solve them. One of them, which is the first one we're going over today, is graphing, right? So just quick examples, quick drawing out, right? So let's say we graph our lines and we get this. See where they intersect? So where they intersect is going to be our solution, and we will write it as the coordinates x and y, right? So like I say, where they intersect is their solution. So they intersect only at one place, that is going to be their solution. On the flip side, let's say you get this and you got another line and intersects at, look at that, it intersects at two places, right? So that means these would be your solutions. And again, you will write them as like your coordinate pair. So you have like x1, y1, and x2, y2. All right. And so this for graphing, wherever they intersect with each other will be your solutions. Now on the flip side, think about this. What if you draw your lines and they just so happen to be parallel? So they have no place that they're crossing, right? Because they do not cross, or in other words, intersect with each other, you have no solution. All right. Now on the other side also, if let's say you did graph all your lines and they just so happen to be the same thing, so they all just become one line, right? This means that you have infinite solutions. All right, and this is how you find your answers for your systems of equations when you're graphing. Now for the other method that you will commonly use is elimination along with substitution, right? These two are very, very common methods that you'll be using for systems of equations to find the answer. You'll use either one depending on which one you're more comfortable with and which one looks easier to use at the time. All right, so let's go with elimination first. So we look, with elimination, you want to get rid of one of the variables first to make it easier. Right? So we look here at these two equations. It's easier to get rid of y first because they both have coefficient value of 1 and, well, in this case, -1, but it's a lot easier to get rid of it. So I'm just going to write out the equations again, right? Now, big thing I always say, put a parentheses around your bottom equation, because if you have a negative sign here, it's going to change all the signs, all right? Now, if you look, you have positive y and negative y. We want to get rid of this, right? Because they have different signs, we are going to add the equations together. You'll see in a second why. So you have x plus -2x is going to give us -x. Y plus -y is going to give us 0. 3 plus -1 is going to give us 2. Okay? Isolate x, so get rid of the negative sign by multiplying -1 on both sides, which would then give us x equals -2. All right, now that we have this, I'm going to substitute x equals 2 into any one of these equations. I just need to pick one of them. I'm going to pick the first one because it looks a lot simpler to solve it from there, right? So let's look. We're going to substitute x with -2, right? So we have -2 plus y equals 3. I'm going to add 2 to both sides because I want to isolate y, and now y would equal to 5. Therefore, my solution is going to be -2, 5. All right. Now we look at the bottom. None of them have a coefficient of 1 for the variables, right? But if we look at here, between x and y, because y's, they both have a common multiple, which is 6, it's easier to manipulate them, right? So we look here, 6 is already, the bottom one's already 6, the top is 2. So in order to make that become 6, I'm going to multiply the top equation by 3. Everything by 3, right? So I'm going to rewrite my equations now. So once I multiply everything for the first equation, I'm going to get 9x minus 6y equals -6. And now I'm going to rewrite my second equation at the bottom here, right, just as it is, because I didn't do anything to it. So I have 5x minus 6y equals 10. Put the parentheses around. Now let's determine if we're going to add or subtract the equations. Now if you look, we have negative 6y and negative 6y. Because these two have the same signs, I'm going to subtract the equations from each other, right? So I'm going to put a negative sign there and see how important this parentheses is. Because if I did not put the parentheses, it only means that I'm going to do 9x minus 5x. And then negative 6y minus 6y, which is not what we want. Now that we have the negative side, it's going to be negative 5x plus 6y equals negative 10. All right, so let's do the math. So 9x minus 5x is 4x. Negative 6y minus negative 6y, so it becomes positive. So negative 6y plus 6y equals 0. Beautiful, we got rid of y. Now negative 6 minus 10 is going to give us negative 16. All right, let's isolate x. So divide 4 on both sides. X is going to be negative 4. All right, now that we have this, I am going to substitute x with negative 4 using any one of these equations. I am going to pick the second equation to use, right? So we have 5 replacing x with negative 4. Look at that. Minus 6y equals 10. Expand the parentheses. We are going to get negative 20 minus 6y equals 10. Group the like terms. Negative 6y equals 30. Isolate the variable, so divide both sides by negative 6. So y equals negative 5. Therefore, our solution for this is going to be negative 4, negative 5. All right. Now the next one that we have is, look, our variables, none of them would coincide with each other. So let's pick a variable that we want to get rid of first, right? So in this case, I want to again get rid of y. If we look, 3 and 2, what is their lowest common multiple? So the lowest common multiple between these two is 6. So how are we going to make 3 here become 6? Well, we will need to multiply everything by 2. How will we make 2 here become 6? We would need to multiply it by 3. So as you can see, both equations now would need to be multiplied by something. All right, so once we multiply, let's do the top equation first. We'll get 8x minus 6y equals 18. And the bottom, once we multiply, is going to be 21x plus 6y equals negative 18. Okay, put a parentheses around. Oh look, different signs. So that means I want to add the equations to get rid of the sign y, right, or the variable y. Well, it's 8 plus 21 is going to be 29x. Negative 6 plus 6 is going to be 0. 18 plus negative 18 is going to be 0. All right, well, I want x by itself, so we're going to divide both sides by 29, and then we're going to get x equals 0. From there, we're going to plug in into any one of the equations that we have. So I'm going to use the first equation. So that means 4 times 0, because that's where x used to be, and now we're replacing it with 0, minus 3y equals 9. This becomes 0. So now we have negative 3y equals 9. Isolate y by dividing both sides with negative 3. We would then get y equals negative 3. All right. So that means the solution for this systems of equation is going to be 0, negative 3. All right. If you have any questions about this, bring it to your deep dive lesson. Haha. Now look. Same thing again, but now we have fractions. So first thing we want to do before we even decide which variable we're going to get rid of is to get rid of the fractions. That way it's a lot easier to see. All right, so let's multiply the top with its reciprocal for the fraction, which in this case is 2. And then if we look here for the bottom equation, we would need to find the lowest common denominator. right? Or the lowest common multiple between 2 and 3, which in this case would be 6. All right, you'll see in a second why. So top equation would now become 2x plus y equals 12. Bottom equation would now become 9x plus 4y equals 51. Ooh, let's look. Between x and y, which would be easier to get rid of? In this case, y, right? Because in order to, you could also get rid of 2 with x, but then you would need to multiply both equations with its lowest common multiple, which in this case, you will need to multiply everything by 9, and you need to multiply everything here by 2. Whereas if you're trying to get rid of y, you will only just need to multiply the top equation by 4, and that's it, all right? So again, I'm going to write my equations at the bottom. So once we multiply the top, we are going to get 8x plus 4y equals to 48. I'm going to write the bottom one as it is because we didn't do anything to it. All right. Parentheses as usual. Now, are we going to multiply? Are we going to add or subtract? Same signs. So I'm going to subtract, right? And then from here, that's going to give us negative x equals to negative 3. I want x to be by itself, so get rid of the negative sign by multiplying both sides by negative 1. So x is going to equal to 3. Now I need to find the value of y, so I need to substitute x with 3 into any one of the equations. Now, we don't necessarily need to take these equations and plug it in. We could also take these ones because they are just transformations of the original one, right? So I am going to take this equation and substitute x with 3 into it, right? So let's look. 2 times 3, because that's where x used to be, plus y equals 12. You get 6 plus y equals 12. Isolate y by subtracting both sides of 6. We'll get y equals negative. We'll get y equals 6. There we go. All right, so that means the solution to our systems of equation is going to be 3, 6. All right. Now, if we look here, it's actually, this one is going to be not too bad. So again, we have a fraction, so let's get rid of the fraction. So we're going to multiply it by 4, right? So we're going to write the top equation as it is again because we didn't do anything to it. Bottom equation is going to be 4y equals 12 minus 3x. Now, as you can see, we would ideally want to put it in this format. So we are going to rearrange the bottom, right? So we're going to add 3x to both sides. So I'm going to rewrite my first equation as it is because we didn't do anything to it. And now we're going to write our bottom equation. So our bottom equation is going to be 3x plus 4y equals 12. Oh, look at that. I mean, we'll see in a second. And let's get rid of x, right? Same signs, so we're going to subtract. 3x minus 3x, 0. 4y minus 4y, 0. Equals 12 minus 12, 0. Oh, look, 0 is 0. When this happens, it means that our solution is going to be all real numbers. So we're going to have an infinite number of solutions. All right, or in other words, all real numbers are solutions. So let's say you get 0 equals 0, 2 equals 2, negative 2 equals negative 2, right? When that happens, it means you have infinite solutions. Now let's take a look at this kind of question, right? So first thing I want to do, I want to determine which variable I want to get rid of. I want to get rid of x. So I am going to manipulate the bottom equation by multiplying everything by 3. I'm going to rewrite the top equation as it is because we didn't do anything to it. Now the bottom equation, we get 6x minus 15y equals to negative 15. All right. I want to get rid of this, so we're going to add the equations because they're different signs. Negative 6x plus 6x is 0. 15y plus negative 15y is 0. So 0 equals, 10 plus negative 15 is going to be negative 5. But hold up, 0 is negative 5? No, that's not true. That doesn't make sense because, 0 is 0, negative 5 is negative 5. And because here we get 0 equals negative 5, that means we have no solution, right? Because like I said, 0 is 0 and negative 5 is negative 5. 0 cannot be negative 5 and negative 5 cannot be 0. And that's why when you have these kind of situations, you have no solution. All right? Alrighty, now we're going to look at the other method of solving systems of equations, which is substitution, right? So with substitution, what we're going to do is we sometimes want to manipulate the equations that we're given and plug it in or substitute it with the variable that it equals to. So let's look. I want to manipulate the bottom equation because so I want to isolate x by itself because it just looks easier. So I'm just going to label my first equation as 1. I'm going to manipulate this one by getting rid of 2y because I want to isolate x, right? So I'm going to get x equals to 6 plus 2y. Now I'm going to label this as my second equation. And now to keep track, I'm going to say substitute equation 2 into equation 1. All right, so what that's going to look, I'm going to replace x in the first equation with 6 plus 2y. So how that's going to look, it's going to be 2 times, x was here, but I'm now replacing it with 6 plus 2y, right? So 2 times 6 plus 2y plus y, because that was the rest of the equation, equals 7. From here, distribute, which is going to give us 12 plus 4y plus y equals 7. Group the like terms, we're going to get 5y equals negative 5. Y equals to negative 1. All right. And now from here, because I know y is equivalent to negative 1, I'm going to substitute y equals negative 1 into, let's see, I'm going to use 2 because it looks a lot simpler than that. You could also use equation 1, and that's completely fine. All right. But I'm just going to use equation 2 for simplicity's sake. So from here, we're going to get x equals to 6 plus 2, replacing y with negative 1. So once we get that, we get x equals to 4. That means the solution to our systems of equation is going to be 4, negative 1. All right. And in order to check also with like elimination method or substitution method, once you get your solution, you would, to check if it's correct, you would just plug it in back into both equations to see if it would equal to the thing that it's given. So in this case, if I were to plug in 4 and negative 1 here, it should give me x. If I plug in 4 and negative 1 here, it should give me 6. If for some reason maybe, I get a wrong answer, right? And I plug it in and it doesn't give me 7 and 6 here, that means my answer is wrong and I would need to go back and check again. All right. So remember, to check, you would just plug these in into here and they should come out as what they are supposed to be. All right. Now if we look at the bottom one, look. I'm going to label this as equation 1. And look, this one is y equals x plus 5. Y is already isolated, which makes it actually a lot easier for me because all I need to do now is substitute this, right, with this in this equation. So I'm just going to label my second equation as 2 and sub equation 2 into equation 1, right? So it means I'm going to replace this y here with this. So how that's going to look, it's going to be x plus 5 equals negative 1. Open the parentheses to give me that. Group all the like terms. It will give me 2x equals negative 6 because I subtracted 5 on both sides. Isolate x by dividing 2, so x equals to negative 3, right? From here, now I know x is negative 3, so I'm going to substitute that into, I'm going to pick, again, equation 2 for simplicity's sake. And then I'm going to get y equals, I know x is now negative 3, so I'm just going to put that there. plus 5. So y would equal to 2. Therefore, the solution to this problem is going to be negative 3, 2. Again, to check the answer, I'm going to plug these into their respective areas, and they should give me, like in this case, all of these two should be negative 1, and all of this, this should give me 2. All right. If you have any questions, bring it to your deep dive lesson. All right, now we have these kind of questions, right? So y equals negative 2x plus 5 and y equals half x. So this is actually a lot simpler, right? Because what it means is that this equals this, but this equals this, which means this equals this, right? So again, I'm going to label my equations, and I'm going to say substitute equation 1 into equation 2, and so that's going to look like, I'm going to replace the y here with negative 2x plus 5 equals to half x, right? And then from here, fraction, let's get rid of it by multiplying it with its reciprocal, which is 2, which would then give us negative 4x plus 10 equals x. All right, let's bring the x over here. We're going to get 10 equals 5x. Isolate the x. So then we're going to get x equals 2. All right. Same thing as usual. Substitute x equals 2 into, let's pick the first equation. All right, so then we'll get y equals negative 2 times 2, because that's where x used to be, and we're substituting it, plus 5. So after we calculate everything, y will be 1. That means the solution to our systems of equation is going to be 2, 1. All right. Now we look at this. First thing that we can do is, we could actually simplify this first, make it a lot easier for us. So I am going to multiply everything by 1/4, or in short, I'm going to divide everything by 4, right? So I'm going to label this as our first equation, and now I'm going to get our second equation, which would be negative 3y plus 2x equals 12. Oh look, 2x. I'm going to substitute 2x with this. So I'm going to isolate 2x now. So we're going to add 3y to both sides, which would then give us 2x equals to 3y plus 12. And this is going to be our second equation. All right, so look, 2x is this. We have 2x here, which means we can substitute equation 2 into equation 1. So we're going to replace 2x with 3y plus 12. So if you look, 3y plus 12 minus 3y equals 12. There's no 2 in front because remember, we're taking 2x by itself as a whole. All right, open the parentheses. And now we're going to group all the like terms. And from here, if you notice, we're actually going to get 0 equals 0, which, look, that means all our solutions, or all real numbers are solutions. In short, we have infinite solutions. All right. Now we look at this one. We can just straight away plug in y in here with 5 over 2x. So I'm just going to do that. So I'm going to sub 2 into 1. That's going to give us 5x minus 2 times 5 over 2x equals negative 10. 5x minus 5x equals negative 10. 0 equals negative 10, but 0 is 0 and negative 10 is negative 10, which means that this is not true. Therefore, we would have no solution. All right. Oh, also I forgot to mention, another way to write no solution is to draw this. All right, if you have any questions about how graphing, elimination, and substitution, and how to use them to solve systems of equations, bring it to your deep dive lesson. All right. Now, some verbiages that may or may not come out during your test is this. When we have one solution, it is known as consistent dependent. When we have infinite solutions, it is, sorry, this is supposed to be independent. When we have infinite solutions, it is going to be consistent dependent. There we go. And when we have no solution, it is going to be inconsistent. All right, so one solution, consistent, independent, infinite solutions, consistent, dependent, and no solution, inconsistent. All right, just some good terms to remember because it may or may not come out during the tests. You may see it in college also. All right. All right, now the next thing that we're going to move on to is systems of inequalities. Alrighty, now with systems of inequalities, the best way to solve them is to graph it, right? So I'm just going to quickly graph my things. So we're going to graph the first inequality first. So y is greater than 4x minus 3. So we look here, our first point, our y-intercept is going to be here, and then our other point will be at 1, 1. And then hopefully this is straight. All right, so imagine, you know, the lines are just super straight. Right, yep. So make sure when you draw lines, it is straight. All right, I'm gonna label this. Oh, actually, if you notice, it does not have the equal sign, so it's gonna be dotted lines. Very careful, be very, very careful about that. So this is going to be y is greater than 4x minus 3. And now I am going to quickly shade this on the region, right? So I know that all my values are going to be on top or above the line. So that means all my values are going to be like, as you can see, around here. Let me just quickly shade that. There we go. Now I'm going to draw my other line, which is y is greater than or equal to negative 2x plus 3. So I know my point is going to be, one of them is going to be here, and the other point coincidentally will be at 1, 1. Right, so I'm going to draw a hopefully somewhat straight line. There we go. I'm going to label this y is greater than or equal to negative 2x plus 3. I'm going to have a different color now. Now, as you can see, this one I also want my equation, the region to be above the line, right? So that means it would be in this area. All right. Now, as you can see where the two areas overlap, which would be, I'm going to color it in red. So this portion here would be where your solution lies. So as long as you take any solution that is within this area of overlap, as you can see, it will satisfy both inequalities. If you take a solution that's on the solid line, it will satisfy both inequalities. If you take a point that is on the dashed line, it will not satisfy the top inequality, right? Because it won't equal to it. So dashed line, you can take any point on it. I mean, solid line, you can take any point on it. Dashed line, don't take any point on it. Definitely take a point that's within the overlap of these two inequalities, all right? So if let's say you were to take a point that's like here, which is 1, 5, it will satisfy both inequalities. If you take 0, 3, it will satisfy both inequalities. If you take 1, 1. It will not satisfy the top, right? So just make sure you take, best definitely is take the one that's overlapping in both of them. Okay? All right. Now the next thing that we have are number and value word problems where we would have to form multiple equations in order to solve them, right? So let's read the problem first. Read it really carefully because we would have to come up with multiple equations. Right, so let's read. Alejandra is ordering ice sculptures and balloon arches to decorate for her company's holiday party. She needs to order a total of at least 15 ice sculptures and balloon arches. Each balloon arch costs $200 and each ice sculpture costs $125. At most, she can spend $2,400. What is the maximum number of balloon arches she can order? So let's first label. I'm gonna designate S as the ice sculptures and B as the balloon arches. This is just to help keep track of what I am solving. All right, so let's look at the first, at our first thing. She needs to order a total of at least 15 ice sculptures and balloon arches. So how that's going to look like, it's going to be S plus B is greater than or equal to 15, right? Because minimum 15, it could be more than that. So that's our first inequality. Now the second one is, let's see, we know that each ice sculpture is $125 and each balloon arch is going to be $200. So then we will be able to write our first part of this inequality as 125S plus 200B is less than or equal to 2,400. All right. Now, in order to find the maximum number of balloon archers that Alejandra can order, we need to realize that the intersection point of like the boundary lines of when we draw these inequalities would be the solution, right? So in order to solve this, we are now going to replace the inequality sign with the equal sign. So now we're going to get S plus B equals 15 and 125S plus 200B equals 2,400. Right, so now I am going to manipulate this so I can substitute it into this. So I'm going to designate this as my first equation. I'm going to manipulate this to isolate S. So we're going to get S equals 15 minus B because I subtracted B from both sides of the equation. All right, so that's going to be our second equation. From there, I am going to substitute equation 2 into equation 1. That's going to give us 125 times, because I'm replacing S with 15 minus B. Right, so we're going to get 125 times 15 minus B plus 200B equals 2,400. Expand or distribute the parentheses, we're going to get 1875 minus 125B plus 200B equals to 2,400. Group the like terms, we are going to get 75B equals 525. Isolate B by dividing both sides with 75. B equals to 7, which means that the max number of balloon arches that Alejandra can buy is 7, and that is the answer. All right, if you have any questions about this, bring it to your deep dive lesson. All right, now for these kinds, these ones are a lot more common in the questions that you will face. All right, so let's read it. You're going to the mall with your friends and you have $200 to spend. To spend from your recent birthday money. You discover a store that has all jeans for $25 and all dresses for $50. You really want to take home 6 items of clothing because you need that many new things. How many pairs of jeans and how many dresses can you buy so you use the whole $200? Tax not included. Alright, so from here, I'm just going to assign letters so I can keep track. Alright, so we look at this sentence here. So I want to take home 6 clothings, right? So it can be any combination, any number of like dresses and jeans. So I'm going to write it as J plus D equals 6, and that's going to be one of our equations. Now the other one is going to be in terms of money, right? So we know jeans is going to be 25 each, so we're going to write it as 25J, because for one jean it's 25. We have 2 jeans, it's going to be a total of 50, that kind of stuff, right? Plus each dress is going to be 50, so plus 50D equals the total amount that we can spend is 200. Alright, so this is in terms of quantities, this is in terms of money. And we want to find a number of quantities that we can have for each jeans and dress. So from here, I'm going to do 2 things to make it simpler. I'm going to isolate J for the first equation. And if you look here, 25, 50, 200, these 3 terms can all be divided by 25. So I am going to divide everything by 25. I'm going to subtract D here, right? So then now our equations are going to be J equals 6 minus D. This is our first equation. Our second equation is going to be J plus 2D equals 8. Oh look, smaller numbers. It's a lot easier to deal with, this, because it's smaller numbers than this. Alright, so whenever you see this and you notice that they can be simplified, do it, because it's easier to deal with smaller numbers. Anyways, now I want to substitute equation 1 into equation 2. Right, so I'm going to substitute this J here, with 6 minus D. So we have 6 minus D plus 2D equals 8. Right, open the parentheses, 6 minus D plus 2D equals 8. Group all the like terms, and that is going to give us D equals 2. Alright, now because I know D equals 2, I am going to substitute that into equation 1, which will then give us J equals 6 minus 2, J equals 4. Therefore, she can buy 4 pairs of jeans and 2 dresses. Alright, and this is how you would answer systems of equations word problems. Alright, and this is the end of your pre-lesson. If you have any questions, as usual, bring it to your deep dive lesson. Alright, thank you for tuning in. Have a good rest of your day.